Hello guys, my name is Ashutosh Godara and we are going to present demo for a spatial computing project. Our topic is optimal pathfinder considering safety and time. Our group is group number 4 and following are group members. Agenda for this demo is first I'll go through with topic overview and then product demo. After that my friend Parth and Priyam will go through with front end and back end source code walkthrough. The topic is optimal pathfinder. So over here we are proposing a solution to calculate the safest and shortest path between two locations in a city which touches the least amount of crime privilege area. We develop a user interface which will take source and destination and address from user, and our backend algorithm will calculate safest and shortest path uh, between these two points. And we took Brooklyn New City as our experiment and data set, and crime data set we are taking static and real. Static we generated it from random number generator, and real data set we downloaded from internet. And these crime hotspot we categorize into two category. One is low dense crime hotspot. Over here we can see that is in the green mapper, and high dense crime hotspot that is red mapper. And our backend algorithm accordingly take these hotspot and calculate the safest and shortest path. In our project, we use Python as a language, and we use Django framework for hosting our application. We also use Python libraries, OSMNX for graph, and Network-KX for algorithm modification, Folium for map representation in our front end. Now let's come to the demo. So this is our landing page of our application. So over here, user needs to give source and destination address in Brooklyn, New York City, which will calculate safest and shortest path. So let me give two addresses, Brooklyn Winery and Canarsie. When I hit submit, it will calculate safest and shortest path, excluding crime privilege hotspots. So over here we can see this is the source and destination, and this is the safest and shortest path, which exclude all the red hotspot which are highly dense crime area, and green one are low dense crime areas. Or algorithm may or may not include them. So over here we can see this is the safest and shortest path. Yeah, that's all from the demo. Now my friend Parth will go through with source code on front end. Thank you.
Hi everyone, myself Partha Thakuria, and I'm going to explain how the front-end design of our project is working. So now from our design diagram, we can see that we are using Django framework for creating the client-server model. So here we can see that we are starting a web server. We are starting a localhost server using the Django run server command. So basically we are running the command python manage.py run server. So here the manage.py file, so it is going to take input as system argument as run server, and it will create a localhost server. And so now after that we are loading the graph and the hotspots. So in our main views of the project, so we are loading these graphs from the pickle files that we have saved in the templates folder. And after that we need to show something to the users. So basically in Django, how it works is we can define multiple projects inside our projects. So we can consider them as applications, and multiple applications can reside inside the same project. So in the URLs file of the main project, so we can see that we have defined our maps application URL for it. So we can go to localhost/maps, and that will start our main maps project. And in the maps URL files, so we have defined different URLs for the maps projects. So default maps, so we need to show something to the users. So we are showing the index views file. So let's go to views.py and see what index is doing. So it is loading the maps index.html file. So we can go to the index.html file and it's loading a form. It will look something like this without any styles. So um, what we are doing, that's we are loading this index.html and we are taking inputs from the user. And after we submit this form, it will be a post action, and these inputs that the user has given, we are taking them and we are processing them. So we, after taking the inputs from the user, we are giving those requests as URL form, and as I have shown how we are resolving the URLs. And now in the views part, we are processing that data. So we can see that in our views.py. So uh, in the index file index.html, we can see that after the form is posted, it is redirected to the, so the action is taken as it is redirected to the show views uh, function. So this show views function, we can see that it is taking the inputs given by the user, as it is taking those inputs from those handles and it is processing them. First, we are checking if the inputs are valid, and then after we are sure that the inputs are valid, then we are using with OSMNX and Folium. And so from the graph that we have loaded from the pickle files, so we are plotting the graph using Folium, and we are plotting the hotspots using Folium. And after that, we are saving the file in route.html, and after that we are rendering the maps show.html, and we can now go to the show.html. We can see that it is rendering a text header, and it's also rendering a iframe, and in the iframe we are giving the URL as the route, and this will render the route views file. And now we can uh, see that that in the views.py, the route is rendering the maps route.html, and this is the same route.html that we are saving after plotting our graph using OSMNX and Folium. So this is the whole implementation from the front end point of view. So we can see that here, so we are using the views middleware, and in models, we are not using anything. We are saving everything in the templates folder as pickle files. And I have shown the templates that we are using, and we are finally loading the map. So this is the implementation from front end point of view. So that's from my side.
Hello everyone, I am Priyam and I'll show the backend source code walkthrough. So let's get started with this. So first of all, like this is our backend source code walkthrough notebook. And firstly, like I want to show what modules that we are using. So the first one that we are using is OSMNX, which is in order to generate the graph for that particular location that we wanted like to consider. And the second one is Boolean in order to represent the safest route that we have calculated on a map. Then GeoPy for processing and converting address into coordinates. Like suppose I give one coordinate, one address like Midwood, and it will just convert that particular address to its respective latitude and longitude locations. Then NetworkX to get the path from the source and destination. and then Ticker to load some pre-trained graph and hotspots that we have already like trained it earlier because it requires like a lot of effort. So we are not training it again like through each and every run. I'll show the implementation part later. Then this first step, like we start is just loading with our graph. So as you can see that I'm using Pickle to load the Brooklyn graph that I have already trained. And let me show you how I'm just doing creating the graph. Here you can see that I have like just put the place as Brooklyn, United States, and using the OSMX module, I'm generating the graph from it. And if I just visualize this particular graph here, you can see that like the whole Brooklyn map is now like a graph is created considering like how the Brooklyn map is being formed with all the connections, like what paths are possible from each and every node. And there are total more than 12,000 different nodes in the Brooklyn map itself. So it's a quite a large graph here. Then next we are again loading the hotspots that we have already processed. So we have used the Brooklyn data set for the crime reports. So it has like different crime reports, and with that we have like the coordinates for it, and we are like say processing it and just converting each coordinate and mapping it to our respective graph. So suppose like there is some from our data set, say like there is from X comma Y coordinate where this particular crime has occurred or something. Then in the graph, you will check like where like what is the nearest like node where this X comma Y location lies, and we will make that particular node itself the hotspot. So we are just like say we have already retained it, and we are just currently like have just loaded it here. And the second thing, like as if we have noticed, there are two different kinds of hotspot. So while analyzing the data set that we have used, we observed that like where there are two different kinds of crime, like locations basically, the two different kinds of hotspots that we are able to form. The first one is like the highly endangered one that you can see that are marked as red, and the second one are like the green ones, which are mild. We have to be conscious like around while traveling to there. But it's not like that you just need to avoid it. But red like you should. Red means like you should avoid it. Now coming to the like say the logic part. So first of all, I just wanted to show you how like the implementation works without like calculating like the safest distance and considering the safest distance and everything. So first, like we are just calculating, like we are just we have defined a function that include that needs a source and a destination, and then using network X, we are calculating the shortest distance, which is coming from like say the this origin node and the destination node. So what we are doing, like first of all, like from the source and the destination, we are getting their XY coordinates, the latitude and the longitude. Then we are checking in the graph like where this particular coordinate lies, which node like that we need to start, and then like using network X, we are calculating the shortest path. Here I've just call the this particular function for Brooklyn binary to Canarsie, United States, and you can see that like it starts from here, and it uses the highway as that is just the fastest way possible from there to here, considering time, and you can see that it arrives here. But if you notice that during this entire journey, it has to cross like a lot of hotspots, like the red hotspots. And this path might be like the shortest, but it's not the safest, considering that you have to cross like these many hotspots. And yeah, it's not the safest path. So next we have like say like modify this function a little bit here in order to like uh, get the safest path that is in like optimally possible, considering again like the time as a factor as well. So there could be two scenarios that we are let's say getting the complete safest part, but it should not. It is like not the shortest then. Like say, so we are like say doing it somehow. How like it will be like the shortest and the safest part itself. So what we are doing, like, so this network X uses Dijkstra's algorithm in order to like compute the shortest path. What we are doing is just like what wherever there is we have this red hotspot alerts like which has like the high alert hotspots. We are just hiding these nodes basically, and then running the Dijkstra's algorithm in order to get like the shortest and the safest path. So if we run this updated function for the same source and destination, that is the Brooklyn binary to Canarsie, you can see that now a different path is coming up. It doesn't goes here because it needs to cross like a lot of hotspots, and it is just dodging all the hotspots and trying to find the shortest and the safest path possible to Canarsie basically. Then like as I have like say said earlier, there are two different types of hotspot that we observe. One is like the high alert one, and the second one is something like mild. And probably you just need to be cautious, but you can still travel through them. So we loaded them inside our map, and we have designed like the final algorithm based on that. Like we will just avoid these red ones, but we will like the user can still pass through these green ones, which are like say your mild hotspots. Uh, but just like the user needs to be conscious when traveling. So the GPS will let you know like when you are traveling with this particular hotspot, like here, and you just need to be conscious around it. And yeah, that's it. Like for the backend source code walkthrough. Ah, thank you.